Pi is the number you get from circles, the ratio of a circle's edge to its width. So to find pi, you'd measure something round, right? Here's a way that uses no circle at all. Draw a bunch of straight, parallel lines on the floor, evenly spaced. Then take a needle, exactly as long as the gap between the lines, and just start throwing it, randomly, over and over. Count how it lands. And out of that pile of random throws, pi appears. This is Buffon's needle, and it might be the strangest way to find pi ever discovered. The setup is simple: parallel lines, all the same distance apart. A needle the same length as that distance. You toss the needle without aiming, let it fall, and ask one yes or no question. Did it cross a line or not? Sometimes it lands cleanly between two lines, touching nothing. Sometimes it falls across a line. That's it, crossing or not crossing. You just keep throwing, and you keep a tally of each. Now here's the heart of it. If you work out the probability that a randomly thrown needle crosses a line, the answer is 2 divided by pi. 2 over pi. Pi, the circle number, sitting inside a problem with no circles, just straight lines and a falling needle. And if the probability of crossing is 2 over pi, then we can flip it around. Pi equals 2 times the total number of throws, divided by the number of crossings. So pi is hiding in a simple ratio of how often the needle touches a line. So let's actually throw them. A few needles in, the estimate is rough, all over the place. But watch what happens as the throws pile up. 10 throws, 100, 1,000. Every time a needle crosses, we update the count and recompute our estimate of pi. And slowly, out of pure randomness, the number settles. 3.1, 3.14. The more needles we throw, the closer it creeps to pi. We didn't measure a single circle. We just threw sticks on the floor. But why pi? Where does it sneak in? The answer is the angle. When a needle lands, it points in some random direction, and that direction can be anything from flat to fully turned, a sweep through every possible angle. And whenever you add up every possible angle of a rotation, like a hidden half circle of directions, pi comes along for the ride. The needle isn't round, but the set of ways it can point is. That circle of directions is where pi was waiting the whole time. So that's 8. Your intuition has lost to birthdays, goats, infinities, the digit 1, and now to a fistful of needles that somehow know the value of pi. Brain, 0. Math, 8. And we've got one more in this run. Next time, the most expensive lie your brain tells you. The feeling that after a losing streak, you're finally due for a win. You're not. And that single misunderstanding is exactly how casinos are built. Subscribe, and I'll show you the math that always wins.